Alright, first off, how to do this lab. We know these numbers over here should look like 0.100, 0.200, 0.300, 0.3, 0.3, 0.300. In terms of numbers, you might have had stuff that would have looked kind of like, oh, I don't know, let's go with 0.551, maybe 0.552. Input, we might say 103, which you need to change to 0.103. So we're going to go and assume that all your units are in the right order here. Now you should notice a trend in this lab. Distance output should be less. After the first one, distance output should be less every single time for the rest of them. So for example, and there's even a pattern. It's done by the factors 2, 3, 4, 5, and 6. If you had 0.301 over here, you probably should have got a measurement of like 0.156 over here. And I'm going to go ahead and guess that it probably took about like 115 grams to pick that up, so you might have had like 0.115 listed here. So anyway, that's basically how this works. So get a blank sheet of paper out, put your name and date, top right hand corner, and this is what's going to be your calculations page. And now we're actually going to run through the formulas and everything you need. Alright, first formula we're going to use is we're going to try and find force output. To find force output, I need you to use mass output times gravity. So that's going to be your first equation. So for me, for my first trial, my mass output is 0.1. So this would be 0.1 times 9.8, which we don't really need a calculator for this one. It's just dividing by 10. So this would be 0.98 newtons. So that's going to be on force output 0.98 newtons. And there's my answer for that. For force input, all I'm going to do for force input is force input equals mass input times gravity. Well, mass input on the first one is 0.103, so 0.103 times 9.8 equals, and let's see what we got for 0.103. 0.103 times 9.8, 0.10009. So basically 1.01 newtons. And that's what I'm going to write down for force input, 1.01. Alright, so now I've got force output and force input. Next is work. What have we got? Work output next. Work output would be force output times distance output. If you remember, the symbol S represents distance in physics. So my force output was 0.98 times distance output, which my distance output on the first one is 0.551. So 0.551, and it was meters. And now we can come in here and figure this out. 0.98 times 0.551 is 0.539. So basically we'll go with 0.54 joules of work was done on that first one. So I'll fill in 0.54 joules. Now, to find work input, you should be able to figure it out. If work output is FO times SO, FOSO, not FOSO, but FOSO, then you can probably figure out work input is FI SI. My FI is 1.01, so this will be 1.01 newtons times my distance input, which is 0.552, and it's meters. And now we can plug that in as well. Looks like we'll have 1.01 times 0.552, 0.557, so 0.56. We'll say 0.56 joules. Alright, one more equation is left. I need to fill that in here. 0.56 joules. Last column left, and we're done with the lab. Efficiency. Efficiency is equal to, now this is going to be a longer equation, work. I always got to sit here and remember it. Work output divided by work input times 100. There's my equation. So work output was 0.54 over work input, which is 0.56 times 100. So 0.54 divided by 0.56 is 0.964 times 100. We'll go 96.4%. So my first pulley was 96.4% efficient. Now, use the same equations to calculate each column. You could go through and do all your FOs, all your FIs, WOs, WIs, then do all your efficiencies. Now you will notice a trend in the lab. The efficiency should go down. You're probably up in the 90s here, and you'll probably end up in the 60s by the time you get down here. Now you will also notice though, you actually use less force, so it gets easier and easier to lift it. So one of the things that would be neat if you could figure out is, why does the efficiency go down? Why does it get easier to lift, but why does the efficiency of the system actually go down as you add more pulleys? So anyway, that's how you'll get all the calculations. For the conclusion to this lab, well, here's your purpose for the lab. Purpose is, the purpose of this lab, this lab is to determine the efficiency of a pulley system. By the way, can I please ask you to spell pulley correctly? But anyway, for your conclusion for this lab, now your materials, you should know what you use for materials. In your conclusion, tell me the efficiency. You might list the 6 efficiencies. You might give an average of the efficiencies. I would rather you just list the 6 efficiencies for the conclusion. And also make a statement as to, somewhere in this conclusion, answer this question. Why does the efficiency decrease as you add more pulleys? So answer that question in part of your conclusion. But anyway, also in the procedures for the lab, only thing that's really picky, make sure you tell key things. Tell how to measure. So in other words, make sure you tell somebody, like if this is the hanger, make sure they know to measure to the bottom of the hanger, because that's an important thing in this lab. Also, make sure they know about the thing moving slow. Make sure they know that it's supposed to go, that it's supposed to fall down very slowly as you do the lab. Alright, other than that, you should be ready to do the lab as of right now. And the only other thing, all you got to do is tell how to do the lab good once for trial 1. After that, all you need to do is come back and say repeat steps this through this for systems 2, 3, 4, 5, and 6, or through systems 2 through 6. So it shouldn't be much to do after you tell how to do it one good time. Alright. And since this is a video and there are no questions, I'll just go ahead and close it down.